So in this example here, what we see, this is called a reciprocal function, because if you look at the function on the left-hand side, what we have is 1 over x, or the reciprocal of x to the power of, the reciprocal of x. And when we graph it, we end up with this interesting image where, this red line represents the graph, and it kind of, it's hard to see, but basically it traces the positive and negative x-axis and the positive and negative y-axis. But the interesting stuff happens as we get closer and closer to 0. Okay, you'll notice that at no point does this graph take on the value 0. In fact, if you look up over here, let me just maybe zoom out, and just go up, and now start to zoom in. Okay, the red line represents the graph of f of x, and as I zoom in, you'll notice that it's close to the x-axis, but it never really touches it. It's always getting closer and closer and closer. Okay, and the same goes with everything on the x-axis. Okay, so this is the y-axis, sorry, and the other one is the x-axis. We're always getting closer. Let me just kind of zoom out here and go back to 0, because that's again where the interesting stuff happens. So as far as the domain goes, x can be any value except 0. Okay, at 0, we don't get anything. As for the y values, y can be any value except for 0 as well. Okay, y will never, take on the value 0 because the graph never touches the x-axis. So over to the left-hand side, you see a table of values for some of them, entered into the formula. If you want to expand that, you can. But again, it's important to note that at the origin, it is undefined, does not make sense.